Welcome to this video involving notes about the converse of results regarding transversals. In this first video, we are going to state 4 new results that we call the converse results. The first one is already pictured on the screen. It says that if a transversal cuts 2 parallel lines, for instance these lines that we just highlighted in blue are congruent, then the corresponding angle pairs, for instance these two that we just marked in red, would have to be congruent. Hopefully that's reasonably obvious. Essentially what we did is we copy-pasted this bottom vertex up to the top vertex, and those angles would be congruent as a result since the lines are parallel. Remember, a postulate is something obvious, and this new postulate is called the converse of the corresponding angles postulate. As such, we will abbreviate it the CCAP, the converse of the corresponding angles postulate. The second result that we are going to consider is called the converse of the alternate interior angles theorem. It's abbreviated CAIAT. And here's what this converse says. If a transversal cuts 2 parallel lines, for instance lines M and N that we've just highlighted in blue on the picture on the screen, then the alternate interior angle pairs are also going to be congruent. For instance, let's look at angles 4 and 6. Now we're actually going to prove this result. Remember that our given statement is always the hypothesis of the if-then statement. Relative to this picture, the transversal T is cutting the parallel lines M and N. So our given is that lines M and N are parallel. We want to prove that the alternate interior angle pairs are in fact congruent. In this picture, let's prove that angle 4 is congruent to angle 6. In order to start our proof, we will place our given in the proof. And the given in this scenario is just that lines M and N are parallel. Well now, given that lines M and N are parallel, we immediately know that angles 2 and 6 must be congruent. So angle 2 and 6 are going to be congruent. We will just state that in our proof. Step number 2, angle 2 is congruent to angle 6. The reason is the converse of the corresponding angles postulate. We just stated that a minute ago in this video. Well, now that angles 2 and 6 are congruent, we want to end up with angles 4 and 6 are congruent. So in our next step, we're able to say that angles 2 and angle 4 are vertical angles. How do we know that angles 2 and 4 are vertical angles? Well, that's just given in our picture. Since those angles are vertical angles, we know that angle 2 must be congruent to angle 4 because of the vertical angles theorem. And now there's just one more thing that we have to connect together. Notice that since angle 2 is congruent to angle 6 and angle 2 is congruent to angle 4, left-hand sides are the same, so the two right-hand sides would be the same. And we can conclude that angle 4 is congruent to angle 6 by the transitive property. That's exactly what we wanted to establish. We wanted that angle 4 is congruent to angle 6, and we now have angle 4 is congruent to angle 6. So this proof is completed, and we have now established the converse of the alternate interior angles theorem. We have 2 more results for this video. First, let's simply overview what's happening. For these converse results, we are beginning with parallel lines. Initially, we said that the corresponding angles would have to be congruent since those lines are parallel. And the angles that are vertical to those corresponding angles must be congruent as well. Similarly, when we look at this picture, the corresponding angles that we've just placed in purple would have to be congruent, and those vertical angles would have to be congruent as well. So ultimately, we end up with just two types of angles in a scenario of this type. We have the angles, the four of them that are in red, and we have the angles, the four of them that are in purple. Looking at that picture, we can determine these two other results. The converse of the same side interior angles theorem states that if a transversal cuts two parallel lines, then the same side interior angle pairs are supplementary. Remember, it's a run on the S's. We have the alliteration. Same sides are supplementary. And also, the converse of the alternate exterior angles theorem will state that if a transversal cuts two parallel lines, then the alternate exterior angle pairs are congruent. The abbreviations for these results: we have the converse of the same side interior angles theorem, CSSIAT, and the converse of the alternate exterior angles theorem, CAEAT. In unit number 2, those acronyms will not be as big of a deal. We will use those acronyms much more extensively in unit number 4. For now, these were the 4 key results involving the converse when dealing with transversals.